Okay, you guys, have had several questions about problem types like this one, so I wanted to go over it. Solving a word problem using a quadratic equation with irrational roots. The problem says a model rocket is launched. That means it's starting off at the ground, okay, with an initial upward velocity, we know it's going up, of 230 feet per second. The rocket's height h in feet after t seconds can be given is given by the following, and the equation is h is equal to 230t minus 16t squared. So let's look at that for just a second and talk about what we know. So this upward velocity means this 230 is going to be positive in the formula. The variable of the t is your velocity. So if the velocity was 100 feet per second, then you would see a 100 right here. This negative 16t squared is your gravity. And since we're starting at the ground, there's no constant in the problem. It would be 0. There's not a constant because we're starting at the ground and we're going up. So it says find all values of t for which the rocket's height is 110 feet. So they've told us that they want the rocket's height, that's h, to be 110 feet. So we're going to substitute the 110 in for h. So my equation looks like this, about 110, is equal to 230t minus 16t squared. And the easiest way to work these, or the best way, is to write your squared term in descending order, and you typically want this to be positive. So all I'm going to do is rewrite this so that the 16t squared is on this side and the 230, and we'll get equal to 0, which is our standard form. So I have 16t squared minus 230t, because I had to subtract it to get it over there, and that's a positive 110 is equal to 0. So now we're in standard form. So I can identify my A. My A is 16. My B is negative 230. And my C is 110. So what I do need now is the quadratic formula, and quadratic formula typically is written in terms of x, and so you see it as x is equal to negative b plus or minus the square root of b squared minus 4ac, and that whole thing is divided by 2a. The fraction bar is under the entire thing. Okay, so this x just means that's the variable in the problem, and in this case it's a t. So my quadratic says t is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a, and I was able to find my a, my b, and my c. So now I plug those values in. So my time is going to be equal to negative 230, because 230 was negative, plus or minus the square root of negative 230 squared minus 4 times 16 times 110, and that's going to be over 2 times 16. So that's just me plugging everything into the formula. That's all I've done. And so now I'm going to do some calculations, and so you need to break out your calculator. So I get t is equal to negative makes a positive 230 plus or minus the square root. And so now I'm going to take that negative 230 and I'm going to square it. So let's see, 230 squared is 52,900. And so negative times a negative makes a positive. Okay, then minus 4 times 16 times 110. 4 times 16 times 110, which is 7,040, and then that's over 2 times 16, which is 32. So my time is 230 plus or minus the square root of And so now you just subtract 52,000 minus 7,040, and you get 45,860, and then that's divided by 32. Okay, so now you're just going to put this on your calculator. This is not a perfect square, it's irrational. That's why it's irrational, because it's not a perfect square. And so you're going to just type all these things into your calculator, okay? So I don't have a calculator right here. I'm just using my iPhone. So I'll show you how I would put this in. So I'm going to take 230, and you do 230 plus that divided by 32, and then 230 minus that divided by 32. Okay, so 230 plus, so 230 plus, and then your square root. Ooh, that's not going to work. Okay, we'll do parentheses. 230 plus 45860 square root divided by 32, and I get 13. So approximately, because you see this decimal is going to keep going on, so we say approximately 13.8796712. Let's say that. Okay, so that was the plus side. So now I'm going to do the minus. Okay, so I'm going to do 230 minus the square root. Okay, so 230 minus, I'm going to use my parentheses to make sure this works out right. So 45,860 square root, close my parentheses, equals, divided by 32, and I get approximately, because it goes on, 0.4953287. I'll stop right there, okay, because those would keep going on. It's irrational, so it would continue on, because they're irrational. Okay, so now if you go back to the directions, it says round your answer to the nearest hundredth. So you've got to stop these off at the hundredths place. So if you are looking at the hundredths place means 2 decimal points. So that's as long as the number can be. But the question is, should we leave it as 0.87 or should we change it to 0.88? And how do we know? Well, we look at the number behind the box, and the box it's a 9, and so it says it's got to go up. So my first height would be, height is equal to 13.88. Okay? Or I'm sorry, that's time. My first time is 13.88 seconds. Okay, my second time, so I know that I can only have 2 digits behind the decimal place, and so I look behind the box and it's a 5. Remember the little rhyme was like 5 or more, raise the score, 4 or less, let it rest. So should it be a 49? Should I let it rest, or should I change it to a 50? Well, because of this 5, it says change it to a 50. And so my second time would be 0.50 seconds, or 0.5, however you want to look at it. So when I look at the rocket's height, so what's going to happen to the rocket is I get 2 times. There's 2 times when this rocket's going to be 110 feet, because as I'm going up, I'm going to hit 110, right? 110 feet. And then as the rocket goes down, it's going to hit 110 feet again. So as it's going up and as it's going down, so think about this for a second. It's shooting up, so 0.5 seconds. Here it is at 0.5 seconds. It hits that 110. That thing's shooting up because it's going 230 feet per second. So boom, that's at 0.5 seconds. It hits that first 110. And then it loops around, and then it takes 13.88 seconds for it to get to the other side. Okay? Okay, so now let's talk about something else real quick. Suppose that instead of they saying they want the rocket's height, when is the rocket 110, what if they say when the rocket hits the ground? How would this change the problem when the rocket hits the ground? So when the rocket hits the ground, what's the height going to be? See, here we switched out the height for 110. But if we're looking for the rocket hits the ground, when the rocket hits the ground, what's going to start off at the ground, right? Okay, that's going to be 0 seconds because it's starting off at the ground. But when it comes back around, it hits the ground again, the height is 0 there also. So if you want to know when the rocket hits the ground, then you know that the height of the rocket is 0 feet because it's on the ground. Okay, so that's how the problem would change. This 110 would change to a 0. I hope that helps.